Hello everybody, welcome back. We are continuing the introduction to networking by Dr. Chuck. We're gonna continue with the transport layer and possibly even more. This book really doesn't seem that heavy. I mean, it's an introduction after all. And yeah, I think it's definitely doable in one weekend. However, so now I'm gonna have 3 hours of stream, 4 hours, give or take. Because then I have to go, but we will see. I think it's gonna be still enough time for something great. So my first question is, why is this here chapter 6? But actually in my notes there are no, it's not chapter 5. Yeah, I already made a mistake, guys. Okay. Because it's not the transport layer, which is the next one, but the domain name system. Aha. What the hell? Really? That's very strange. So instead of asking too much, we're gonna next layer up the transport layer. So we are not gonna talk about the transport layer. It's the domain name system. Okay, fair enough. The domain name system lets you access websites by their domain name, like khanacademy.org. So you don't have to keep a list of numeric internet protocol addresses like this one. IP addresses are determined by where your computer connects to the internet. When you have a portable computer, you move from one location to another, you get a new IP address at each location. Since no one connects to your portable computer, it does not matter if your IP address changes from time to time. But since so many people connect to a web server, it would be inconvenient if the server moves to a new location and needed to change its IP address. When your computer makes a connection to a system using a domain name address, the first thing your computer does is look up the IP address that corresponds to the domain name. Yes, so I'm gonna put, of course, the timer, because yesterday that was really beneficial for us. So for this type of studying, the 25 minutes, 5 minutes break is absolutely a good idea. So just 1 second. Okay, since no one blah 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 blah. But since so many connect to a web server, it will be inconvenient if the server moved to a new location and needed to change its IP address. When your computer makes a connection to a system using a domain name address, the first thing your computer does is look up the IP address that corresponds to the domain name. Then your computer makes the connection using the IP address. Adding the separate step of looking up the IP address for a DNS address also makes it easier to move a server from one location to another. The server is given a new IP address and the entry for the domain address is updated. Once the DNS entry is updated, new requests for domain name are given the new IP address. Since end users access most servers using domain names and never see the IP address, the server can be moved to a new network connection without affecting the end user's ability to access the server. Ta-da! So that's the DNS. Fixed IP addresses for a web server is important, is necessary. Yeah, fair enough. If you recall from the previous section, IP addresses are allocated based on where you connect a new network to the internet. Domain names are allocated based on organizations that own the domain name. At the top of the domain name hierarchy is an organization called International Corporation of Assigned Network Names and Numbers. I know I can be wanna be. Chooses the top level domains TLDS like .com, .hu, .org, and assigns those to other organizations to manage. Recently, a new set of TLDs like club and .help have been made available. That's nice. I can also assign two-letter country code top-level domain names like .us, blah blah blah, to countries around the world. We call these country code top-level domain names. Countries often add second-level TLDs like for commercial organizations within the UK. Policies for applying for domain names with any particular CCTLD vary widely from one country to another. Once a domain name is assigned to an organization, the controlling organization is allowed to assign subdomains within the domain. As an example, the .edu top-level domain is assigned to the EduCase organization. EduCause assigns domains like umich.edu for higher education institutions. Once the University of Michigan is given control of the umich.edu, it can make its own choices for subdomains within its new domain. Domains ending in .com and .org can be purchased by individuals. The individual owners of those domains are allowed to manage their domain and create subdomains under it for their own use and used by others. Very, very interesting part. Thank you so much. When we look at an IP address like this one, the left prefix is the network number. So in sense, we read IP addresses from left to right, and the left part of the IP address is the most general part of the address, and the right part of the address is the most specific. Broad, narrow. For domain names, we read from left to right, from right to left. The most general part of this domain name is the .edu, which means higher education institution. The subdomain name umich.edu is particular higher education institution. That's very, wow, what a short chapter. Oh my god, that's extremely short chapter. While the domain name system is not one of our 4 layers in the model, it is an important part of making the internet easier to use. Domain names allow end users to use symbolic names for servers instead of numeric Internet Protocol addresses. By adding a service that maps domain names to IP addresses, we can move servers from one internet connection to another connection without requiring users to manually change their configurations to connect to a server. If you would like to purchase a domain for yourself or for your company, you can choose from any number of domain name registers. I see. Okay, let's do the questions. Quiz time. What does the domain name system accomplish? It allows network connected computers to... Yeah, I think that's the one. Which organization? ICANN. I know ICANN. Which of these domain address is this one? Which of this not something a domain owner can do with their domain? Sell, create new tuple, assign an IP address to the domain or subdomain. Okay. Five minutes, but I think this was so little. Yeah, it will be nice. I will go to play badminton today. It will be very nice. I need some movement because this is unacceptable. So the next layer up from the internetworking layer is the transport layer. A key element of the internetworking layer is that it does not attempt to guarantee delivery of any particular packet. The internetworking layer is nearly perfect, but sometimes packets can be lost or misrouted. But users of the... Actually, before we continue, I would like to really, because something is bugging me, I want to ask ChatGPT in which layer the CM, the carrier sense thingies exist. I wanna check this. In which layer carrier sense multiple access with collision detection is exist? Yeah, so it's in the link layer. Internet networks to control. So it's here. Anyway, let's go. So the next layer up from the internetworking layer is the transport layer. Key element of the internetworking layer is that it does not attempt to guarantee the delivery of any particular packet. The internetworking layer is nearly perfect, but sometimes packets can be lost or misrouted. But users of the network want to reliably send entire files or messages across the internet. A network is not much good to us if all it can do is send packets that are received most of the time. For the network to be useful, all of the packets need to be reassembled into the right order to reconstruct the message on the receiving system. The network must also deal with packets that arrive out of order or never arrive at all. The transport layer is where we handle reliability and message reconstruction on the destination computer. Just like the IP layer, the transport layer adds a small amount of data to each packet to help solve the problems of packet reassembly and retransmission. What the hell is going on? Okay, 5 minutes break. Wait a second. No. If you were to look at the packet going through across one of many links between its source and destination computers, you would see link header, an IP header, and a transport control protocol header along with the actual data in the packet. The link header is removed when the packet is received on one link, and a new link header is added when the packet is sent out on the next link on its journey. The IP and TCP headers stay with the packet as it is going across each link in its journey. Remember that the packet may go across several types of link layers as it is routed through the internet. At least we already dealt with headers, right? We even get to the point where we can find the header and remove the new line and everything. So that was that's nice that we know this. So it's the link header. If you look at a packet going across one of many links between it, you would see link header. Miért macskáskodunk? Yeah, this is an important part because I'm actually confused about this a bit because I thought the link layer, right? I even made this mistake in one of the questions before because I thought that, okay, I have this in my computer, this is my link layer, it goes to the router and that's it, goodbye. We are already in the internetwork part. in the internetwork part, and basically from there we're gonna let go of the link layers. We don't care about link layers anymore. But that's actually not true, because I guess it's goes around like this. Like, okay, I'm gonna go from link layer to internetwork layer, and these two are playing together, because from another router there's another link layer, right? We can ask ChatGPT. So this is why ChatGPT can be very useful. Just let's ask: is a link a cable from a router to another router is a link layer? Yes. Yeah, I mean, so far, what can I say? I can say that the link layer, where everything begins. So wait, so the link layer has this, that I'm sending the packet. I have the carrier sense. So I'm sending a packet, I'm making sure it was received, and I'm sending the next one. If there's collision, I will wait. So this all happens in the link layer. So in the internetworking layer, what do we know? The internetworking layer, okay, can I say the internetworking layer is in the router? The internetworking it's more accurate. It's more accurate to say that the functionality associated with routing and Ethernet networking resides within the network layer, rather than attributing it to a specific networking layer within routers. Okay, I see. Routers are a key component in the operation of the network layer and routing of packets across internetworks. Yeah. So routers are to support the internetworking layer, and not the other way around. It's not we invented the internetworking layer so it can function with routers. It's the other way around, I guess. But anyway, the IP header holds the source and destination internet protocol addresses, as well as the time to live for the packet. The IP header is set on the source computer and is unchanged other than the TTL as the packet moves through the various routers on its journey. Yeah, this is super important stuff, so I'm gonna just write it down. What the fuck? As the destination computer receives the packets, it looks at the offset position from the beginning of the message so it can put the packet in the proper place in the reassembled message. Simply by making sure to put the packet data at the correct position relative to the beginning of the message, the transport layer easily handles packets that arrive out of order. If it receives a packet further down the message, it places the packet in a buffer, keeping track of the fact that there is now a gap in the message that is being reconstructed. When the earlier packet arrives a moment later, it fits perfectly into the gap in the reassembled data. To avoid overwhelming the network, the transport layer in the sending computer only sends a certain amount of data before waiting for an acknowledgement from the transport layer on the destination computer that the packets were received. The amount of data that the sending computer will send before pausing to wait for acknowledgement is called a window size. We know this. The sending computer keeps track of how quickly it starts to receive acknowledgements from the receiving computer. If the acknowledgements come back quickly, the sending computer increases its window size, but if the acknowledgements come back slowly, the sending computer transmits less data. By adjusting the window size, transmitting computers can send large amounts of data quickly over fast connections that have light loads. When sending data over slow or heavily loaded links, they can send the data in a way that does not overwhelm the network. If a packet is lost, it will never arrive at the destination computer, and so the destination computer will never send an acknowledgement for the data. Because the sending computer does not receive an acknowledgement, it quickly reaches the point where it has sent enough unacknowledged data to fill up the window and stops sending new packets. At this point, both computers are waiting. The sending computer is waiting for an acknowledgement for a lost packet that will never come, and the receiving computer is waiting for a lost packet that will never come. Oof. This is such a sad story. To make sure that the computers do not wait forever, the destination computer keeps track of the amount of time since it received the last packet data. At some point, the receiving computer decides too much time has passed and sends a packet to the sending computer indicating where in the stream the receiving computer has last received data. When the sending computer receives this message, it backs up and resends data from the last position that the receiving computer had successfully received. The combination of the receiving computer acknowledging received data, not allowing the transiting computer to get too far ahead, and the receiving computer requesting the sending computer to back up and restart when it appears that data has been lost creates a relatively simple method to reliably send large messages or files across the network. While the transport layer is sending a stream of data, it continuously monitors how quickly it receives acknowledgements and dynamically adjusts its window size. This ensures that data is sent rapidly when the connection between computers is fast and much more slowly when the connection has slow links and heavy load. Oh my god, so there are multiple transport layers. Jesus. Jesus. I'm sorry. I'm sorry I'm making stupid noises again. So anyway, let's see. Keeping late messages. Do 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 do. The sending computer keeps track of how quickly it starts to receive acknowledgement. Fuck. The sending computer keeps track of how quickly it starts to receive acknowledgements from the receiving computer. The acknowledgements, yes, okay, I know this. We already talked about this in the first chapter. So I'm gonna finish this part and then break. When the sending computer receives this message, Why I cannot write? What's going on? I cannot write. Literally cannot write. The transport layer. Olivier doesn't like transport layers. Okay, transport layer in operation. everything hurts, literally. Everything hurts. Anyway, so the transport layer in operation. The transport layer in operation. One of the key elements of the transport layer is that sending computer must hold on to all of the data it is sending until the data has been acknowledged. Once the receiving computer acknowledges the data, the sending computer can discard its sent data. We can look at this graphically when a message is broken into packets. Here the first 10 packets of the message has been sent and acknowledged by the destination computer, A's. Okay, so this is actually no or no? What do you mean? Yeah, I guess, okay, so this little thing here is actually for the previous one. Do you guys see anything? Yeah, okay. Here is the first 10 packets of a message has been sent and acknowledged by the destination computer, A's. The sending computer has sent 6 more packets and then stopped because it reached its window size. There are 3 packets that have been sent but not received. Since there are many hops in the network, it is very common for more than one packet to be en route in the network at the same time. The transport layer on the receiving computer has received and acknowledged 10 packets and delivered them to the destination application. The transport layer on the destination computer has received more than 3 packets, but 1 packet is out of order. Receiving a packet out of order is not a cause for concern if the missing packet arrives in a reasonably short amount of time. As long as all the packets are received, the receiving transport layer will reconstruct the message, fitting packets together like puzzle pieces, and deliver them to the receiving application. We will talk about application layer in layer material. I cannot wait to read more about the application layer. Alszik a kis cica. Hogy alszik a kis cica? És nem nyávog. Megunta a kimászkálást. Végre visszatért. The purpose of the transport layer is to provide reliable connections between network applications so those applications can send and receive stream of data. For an application, this is as simple as asking the transport layer to make a connection to an application running on a remote host. We call the application that initiates the connection to the local computer the client, and the application that responds to the connection request the server. We call the combination of two network applications at the ends of the connection a client-server application because the two pieces of the application must work together. A lot of engineering has gone into the lower three layers of our architecture to make it easy to open up connection to a remote computer and then send and receive data over that connection. When a client application wants to make a connection to a remote computer, it is important that the connection is made to the correct server application on that remote computer. A remote computer might have any number of different server applications running at the same time. Example server applications would include web server, video server, mail server. For instance, a web client, a browser, needs to connect to a web server running on the remote computer. So a client application not only needs to know which remote computer to connect to, it also needs to choose a particular application to interact with on the remote computer. We use a concept called ports to allow a client application to choose which server application it wants to interact with. Ports are like telephone extensions. All of the extensions have the same phone number, but each extension has a different extension number. When the server application starts up, it listens for incoming connection on the specified port. Once the server application has registered that is ready to receive incoming connections, it waits until the first connection is made. So that client application knows which port to connect to. There's a list of well-known default ports for various server applications. Wow, okay, so this is very cool. Yeah, this is very cool. We need this. These are the normal ports for this application. Sometimes servers will make applications available at non-standard ports. If you're doing web development, you may run into a web server at standard port like 3000 if you see URL like blah blah blah. Very nice. And we are done with this chapter. This is very nice. Okay. I should make a coffee. Let's make a coffee. Is it legit to make a coffee? I should still have 10 minutes of studying time. But I'm gonna pause. I'm gonna have a coffee and I'm gonna you know, do this test and everything. Okay, yeah. Yeah, I started to have coffee and Ritalin. That's strange, actually, because I was like, I stopped coffee for 4 months, almost 3 months, like no caffeine, only on days off. And now, actually in like small amount. Okay, this is instant coffee anyway, so it's not gonna do anything. But even in the office, I had like and it was fine. That was on Thursday. That was super nice, actually. That day was super nice. Anyway. Okay. Almost spilled myself. We use a concept called ports to allow client applications to choose which server application it wants to interact. Once the server application has registered that it is ready to receive incoming connection, it waits until the first connection. Once the server application has registered that it's ready to receive incoming connections, it waits until the first connection is made, so that client applications know which port. There is a list of well-known ports, default ports. Server that starts, it listens for incoming connections on the specified. It's messy. indicates that your browser is going to use the web protocols to interact with the server, but connect to a port 80 instead default port 80. Okay, let's see the questions. So this is gonna be a doozy. This is gonna be serious. I know. What is the primary problem the transport control protocol layer is supposed to solve? Deal with lost and out of order packets. What is in the transport control protocol header? Ooh, shit. Okay, wait. So this is cool. Because I know that IP address in stem to live is in the internetworking layer. It must be. I think it must be the offset. It should be the offset, no? Foo. This is I don't know. Either the time, but I think time to live was in the internetworking layer. Should be. Why is window size important for the proper functioning of the network? Because packets are too large and were clogged. It limits the number of hops a packet can take before it's dropped. It limits the number of hops a packet can take before it is dropped. What happens when a sending computer receives an acknowledgement from the receiving computer? The resends sends more data up to the window size. Which of these detects and takes actions when packets are lost? I think the sending computer, no? Which of these retains data packets so they can be transmitted if packets are lost? The sending computer. Which of these is most similar to a transport control protocol port? The train station. Which half of the client must start first? The client. Ooh, wait. Oh my god, yes, the server. Which port is the DNS? Oh my god. No idea. I guess 80. No, the 80 is for the... Oh shit. Now you put me on spot. Because 80 is for the internet protocol. Yeah, no idea. Oh my god. So these you really have to memorize these. So this one, TCP header. What is in the TCP header? I would say port number and offset. And which one I'm not sure about. Yeah, the sending computer. Which of these detects and takes action when packets are lost? So I'm sending a pack. I'm the sending computer. I'm sending my packets, and I'm listening if it's received. I'm sending I'm waiting for the acknowledgements. I don't receive. I'm waiting for the acknowledgements. If there is no acknowledgement sent, I will stop sending and wait. And then what? What happens then? Yeah, well, okay, let's see. Why is it window size? It limits a number of hops. It prevents too much data because packets are too large will clog. Okay, so I guess that's the one. So a receiving computer. It's not a train station. Port. You mean port. Okay, my bad. Yeah, I have to memorize the port numbers apparently. So incoming mail retrieval, DNS domain name resolution. Why is it resolution if it's anyway 53? The application layer. Break time. Application layer, chapter 7. We have been working from the bottom to the top of our 4-layer transport control protocol / internet protocol network model, and we are finally at the top. The application layer is where the network software like web browser, mail programs, video players, or network video players operate. We as users interact with these applications, and the applications interact with the network on our behalf. Client and server applications. It is important to remember that two parts are required for a networked application to function. The architecture for a network application is called client/server. The server portion of the application runs somewhere on the internet and has the information that users want to view or interact with. The client portion of the application makes connection to the server application, retrieves information, and shows it to the user. These applications use the transport layer on each of their computers to exchange data. Anyway, to browse a web address like khanacademy.org, you must have a web application running on your computer. When you type an address into your web browser, it connects to the appropriate web server, retrieves pages for you to view, and then shows the pages. The web browser on your computer sends a request to connect to khanacademy.org. Your computer looks up the domain name to find the corresponding IP address for the server and makes a transport connection to that IP address, then begins to request data from the server over that network connection. When the data is received, the web browser shows it to you. Sometimes web browsers display a small animated icon to let you know that the data is being retrieved across the network. On the other end of the connection is another application called a web server. The web server program is always up and waiting for incoming connections. So when you want to see a web page, you are connecting to a server application that is already running and waiting for your connection. In a sense, the transport inter-network and link layers along with domain name systems are like telephone network for networked applications. They dial up different server applications on the network and have conversations with those applications to exchange data. Yeah, now it's not working, unfortunately. Yesterday was good. Now it's absolutely not working. So today it was it's been 2 hours, right? It must have been 2 hours. I did it before the stream. And yeah, yesterday was really, like, I think it was like working out pretty well, but today not really. So 2 hours ago it was 10 milligrams of Ritalin, and I lost it. It's gone. It's gone, and now it's extremely hard to focus. I literally even have like this, yeah, like heavy brain feeling, and yeah, it's just physically hard to focus right now, unfortunately. But we are aware about this. This is something that, this is why it's not easy, and this is why probably not everyone do this in general. But many people are studying, so props to them. Maybe I just need more water. Maybe I didn't hydrate enough. It will be good. We will do this part or some more, and 12:30 you can have food, so you can have something. 12:30 we will end the stream, so in 1 hour, and I will go to do my little thing, my game. So I have some physical activity. Then we go back and we can continue, really. So I would return around 4, 5, and we can do another stream until like 8. That's a plan. We have a plan. Let's stick to it. Application layer protocols. Just like people talking on telephones, each pair of network applications needs a set of rules that govern the conversation. In most cultures, when your phone rings and you pick up the phone, you say hello. Normally, the person who made the call, the client person, is silent until the person who picked up the phone, the server person, says hello. If you ever called someone who does not follow this simple rule, it can be quite confusing. You probably would assume that the connection was not working, hang up, and retry the call. A set of rules that govern how we communicate is called protocol. And quite honestly, I think this can really, the reason why it's not working or not as you expect is also because of how you use the lack of, the quality of the sleep and so on. And yesterday basically, this is super side note, but ADHD related side note is that yesterday I finished at 6, and I took half. I went to pick up my food, came back, and another half. And it was really honestly, it was for nothing, really. There was no reason to do that again. That was after 8 o'clock. And I think you'd really need to time, like, it has to be really far from bedtime as well. And also, I don't think that, this 3 times, like, if you want to do it 3 times, you really have to do it after, 6, that's it. But on the other hand, this whole urge of redose is our enemy, and we shouldn't. We have to be okay and allow ourselves to, this is what we have. You can do what you can with it, but if it's gone and you feel like it's not working anymore, this is what the most you could have done for the day. And you just have to release the temptation. And many times when you release it, I release the temptation when, even before therapy, I felt like many times like, I should read those. Makes no absolute sense. Makes no sense. It never helps you in a way, and it only makes you feel worse every time. So the only time a read those, let's say, helped me was when I had a really clear idea that I want to do something. Like after work, 6 p.m., and I was sitting here and like, hey, I can just practice guitar. And that was really great because I can really felt the focus and everything. So if you have like really clear idea and it's early, it's not after 8, it's, I think it's allowed. But otherwise, if you, yeah, what was the point yesterday? There was absolutely no point of doing that because I just went to pick up my food. I wasn't doing anything productive. And when I came back home, it was also already not really helping me because I was already tired and everything. So it's like we always go the same circles. And we can say now, like with clear, like how it should work, and then we always keep repeating the same mistakes, and it's a bit tiring. A set of rules that govern is called protocol. The definition of the word protocol is a rule which describes how an activity should be performed, especially in the field of diplomacy. So we need a Ritalin protocol, basically. Write this down. The idea is that in formal situations we should behave according to a precise set of rules. We use this word to describe network applications because without precise rules, applications have no way to establish and manage conversations. Computers like precision. There are many different networks applications, and it is important that each network application have a well-documented protocol so that all servers and clients can interoperate. Some of these protocols are intricate and complex. The protocol that describes how web browser communicates with a web server is described in a number of large documents, starting with this one, request for comment. The formal name of the protocol between web clients and web servers is the Hypertext Transfer Protocol, or HTTP for short. When you put HTTP or HTTPS on the beginning of a URL that you type into the browser, you're indicating that you would like to retrieve a document using the HTTP protocol. If you were to read the above document and go to section on blah blah blah, you find the exact text of what a web client is supposed to send to a web server. One of the reasons that HTTP is so successful is that it is relatively simple compared to most client-server protocols. Even though the basic use of HTTP is relatively simple, there is a lot of detail that allows web clients and servers communicate efficiently and transfer a wide range of information and data. 6 different documents describe HTTP protocol in a total of 305 pages. It might seem like a lot of detail, but the key in designing protocols is to think through all possible uses of the protocol and describe each scenario carefully. This is insane. How? Thank you so much. This is not what I wanted, but okay. Can I? Should I? Ooh, I can send this. I think I already sent this to the Kindle, but we could do this. See, this is something we can do on the way. Let's read. But I think no, we should absolutely read about something else. We need to read about more technology, more relevant technology for us. Let's say that. I have no idea what's going on. Absolutely no idea what's going on. Maybe what you feel is really the amount of knowledge, right? Like you are basically in a mind gym now, yeah, because you're practicing focus, you are learning new terms, you are imagining how things work, you basically develop something. So obviously you are using your brain, and it as you use your brain it gets sore or whatever. Like imagine really this is a mind gym right now and this is what you feel. I just really hope you can really like after this year, being able to study is gonna be like this, like no questions asked. The formal name of protocol between web client HTTP hypertext. We know this. We know this part. So if we apply protocol to our lives as well, we would be much more successful and we would be well prepared. If we really, let's say we're gonna do a Monday protocol and we can actually like imagine really each scenario that could happen and handle it accordingly, would be nice. Anyway. In this section, we will manually exercise in the HTTP protocol by pretending to be a web browser and sending HTTP commands to a web server to retrieve data. To play with HTTP protocol, we will use one of the earliest internet applications ever built. The Telnet application was first developed in 1968. Wow, the same year Electric Ladyland was released, and was developed according to one of the earliest standards of the internet. This standard is only 5 pages long, and at this point you probably can easily read and understand most of what is in the document. The Telnet client application is so old that it is effectively a dinosaur, as it comes from prehistoric times in terms of internet age. Will this open? Please open it. That's so weird. Thank you. Yeah, you guys are not gonna be able to read this. The internet was created in 1985 by the NSFNet project, and the precursor to the NFSNet called ARPANET was brought up in 1969. Telnet was designed and built even before the first transport control protocol / internet protocol network was in production. Interestingly, the Telnet application is still present in most modern operating systems. You can access Telnet from the terminal. The Telnet application was also present in Windows through XP, but is not included in later versions of Windows. If you have a later version of Windows, you can download and install a Telnet client to do the examples in this section. Telnet is a simple application. Run Telnet from the command line or terminal and type this command. Hopefully it will work. Hopefully it will work. Let's see. The first parameter is a domain name. An IP address would work here as well, and a port to connect to on that host. We use the port to indicate which application server we would like to connect to. Port 80 is where we typically expect to find an HTTP server application on the host. If there is no web server listening on port 80, our connection will time out and fail. But if there is a web server, we will be connected to a web server, and whatever we type on our keyboard will be sent directly to the server. At this point, we need to know the HTTP protocol and type the commands precisely as expected. If we don't know the protocol, the web server will not be too friendly. Here is an example of things not going well. We type telnet in the terminal requesting a connection to port 80, the web server, on the host drchuck.com. You can see as our transport layer is looking up the domain name, finding the actual address is blah blah blah, and then making a successful connection to that server. Once we are connected, the server waits for us to type a command followed by the enter or return key. Since we don't know the protocol, we type help and enter. The server is not pleased, gives us an error message, and then closes the connection. We do not get a second chance. If we do not know the protocol, the web server doesn't want to talk to us. But let's go back and read the section of the document, and let's try again the request using correct syntax. Yeah, it disappeared. Then nothing happened actually. So okay, sorry, I desperately need a break, a bathroom break. But actually it's time for a bathroom break anyway, so So I have to understand if this is working or not. Telnet Dr. Chuck. See, but it's connecting, nothing happens. We don't see anything. So what we have to write. I'm sorry, this is not what I want. See, I'm not getting any response or anything. Maybe I have to really restart though. I'm sorry, but yeah, probably I have to restart. Because when I enabled, yeah, this is not gonna work. Yeah, I think I have to restart because when I enabled Telnet, it said, the guide said I should restart, but the Windows itself didn't ask me to restart. So I probably cannot do this. I should try it without after restarting. We make connection to the web browser, again using Telnet. Then we send a get command that indicates which document we want to retrieve. We use version of 1. What if I just use it in the no, never mind. We use version of 1.0 of the HTTP protocol because it is simpler than HTTP 1.1. Then we send a blank line by pressing return or enter to indicate that we are done with the request. Since we have sent the proper request, the host responds with a series of headers describing the document followed by a blank line that it sends the actual document. Since we have sent the proper request, the headers communicate metadata, about the document that we have asked to retrieve. For example, the first line contains a status code. In this example, the status code of 200 means that things went well. Status code of 400 in the first line of the headers indicates that the requested document was not found. A status code of 301 indicates that the document has moved to a new location. The status codes for HTTP are grouped into ranges. 2XX codes indicate success, 3XX codes are for redirecting, 4XX codes indicate that the client application did something wrong, and 5XX code indicates that the server did something wrong. This is a hypertext markup language document. So it is marked with tags like H1 and P. When your browser receives the document in HTML format, it looks at the markup in the document, interprets it, and presents you a formatted version of the document. Nice. So yeah, but if we really want to demonstrate something like this, I guess this is what we did here. Right, right. Never mind. let's make notes from this one. Yeah, let's have a okay. So what we should do, at least explain the headers, right? So, for example, here, so in this code, okay, I know you guys not gonna be able to see it, right? Impossible. Ah, no, you can see it. Okay, never mind. So let's at least check. Here's we have this beautiful socket, and we can even adjust this program that we're gonna demonstrate this page, right? And it's, yeah, HTTP1. It's gonna be Dr. Jock. And here, see, the get here means that we are complying to the protocols of the HTTP protocol. That the HTTP protocol clearly says you have to communicate with me with this get and the new line. So this is makes sense. It's just HTML. This is a fucked up code. This is a stupid code, but I'm sorry, guys. I have to change something. So CMD, it'll be like how it's supposed to look like. Get.url. Yeah, I don't like to do this input thingy. Nice. But I don't think this is good enough. Leave me alone. Maybe I don't need to add the www. I don't know. Maybe. Yeah, my code doesn't work. My code actually is not working. because it should read any page, right? So what's going on? HTML. But it automatically takes us to HTTPS though. So maybe there is no version of like normal HTTP before. Or let's try okay, let's switch the host name. Can you stop this code, please? Thank you. Let's try but I don't think this is again not gonna work, but okay. So if we change, I don't think it's gonna work, but so 443, 443. The plain HTTP request was sent to HTTPS port. This will plain, yeah. Bad request. Yeah, the reason why this is working is because we are already opening a file, right? We already have exactly what we want. But this, in this instance, we open like an HTML file, right? So I don't think even here it's not gonna work. See, that's very interesting. Wait, okay, I know I did something stupid. Oh no. Go back. Undo, redo everything I did. My brain is dead, literally. Yeah, the request URL was not found on this server. Why is that? Why is this not working? Because it does exist, right? We obviously it exists. I guess really because it's a HTTPS. Or maybe it's, yeah, something which you have no idea about. But this is cool. This is interesting. Like we actually can ask. Like I have no idea why it doesn't work. What if I just put there HTML? It's gonna be HTML. Hypertext markup language. ChatGPT time. It's time. I discussed this with my colleague, and she said, it's not, as long as you're studying, it's not cheating. It's you're saving time. So I'm gonna like why this doesn't work. And also there are like things which are so basic, and I would have no like where I would just try endlessly until I go crazy, right? Your HTTP request is not properly formatted. You're providing a full URL in the GET request line, which is not standard. Instead, you should only include the path. Additionally, the hostname should be provided in the host header. Honey is the most annoying thing ever. I need to find make a cult where we're gonna say honey is the most, like we're gonna okay, I don't know where I wanted to go, but yeah, honey is so annoying. It's everywhere. Like I cannot handle honey without always ending up on something where it's not supposed to. So introduction to networking. So here, but that's the thing. Here we already get the page. We already ping it with the talent. But with our socket program, we cannot do that. So what we can do is just keep, like we don't get the whole page, but just the and we have a bunch of stuff now. Okay, cool. Still not found. See, ChatGPT, or you made a mistake. This is not working. Ah, I'm so stupid, Jesus, because I'm connecting to the data.purg, you see, and this is not supposed to be. I'm supposed to connect to the, okay. Jeez. Yeah, of course it's not gonna work. Oh my god, so I have to go to drchuck.com. Hopefully it's gonna work like this. And then we're gonna get to the page. Here's the cat. drchuck.com. And in that case, we don't actually need the let me rewrite this. Let me go back to my. Yeah, that was the problem, because the MySock Connect was having incorrect information. Still not found. Hostname. Hostname is URL split 2. So what is the hostname? The hostname is this guy here. So that's why we can connect, right? And the URL is the whole URL. So we still have the whole URL here. I don't understand. So okay, let's check. Yeah, the host name is just this without anything else. So, which means it should work. This should be the host name. But we already have the host there. Why would we add the host? It doesn't make sense. This doesn't make any sense. So maybe the example is messed up. Connection keep alive. Do you wanna explore, Cat? You can go out because soon I have to go anyway. Yeah, we had a little, we got sidetracked for a little bit, but it's okay because it's relevant to our mental health. Wrap the socket with SSL TLS. SSL underscore sock. SSL wrap dot no SSL dot wrap socket my sock. My little sock. I missed the line. So we don't need this stuff. So it's a different way of it's gonna be a different way of connecting. I don't know what I'm talking about. Okay. What if we just do this? See, it doesn't work. See, like basically he's not, you're not on the top of your game, by the way. Yeah, you're not on the top of your game at all. Trace back, mostly line 9. Anyway. We have to go soon anyway. We have to go soon. So yeah, it still moved permanently. So that's nice. So it means that, you know, this basically this example is not probably not up to date. Yes, that's it. So the book is not updated. That's it. So you had no problem. You did nothing wrong, Gergely. This is fine. Like this program is also, so this program is nice, right? Or no? Let's just go back in the past. That's this whole rabbit hole of going to SSL. That was not necessary. Yeah, it moved permanently. Okay, I'm nervous about my cat. I just let him out, so this is where we end now, and we're gonna continue later. We're gonna have lunch, we're gonna go have some sports, then come back. Hopefully my brain will get some air and everything else, so I will be able to, I will definitely could finish the book I just hope I will be more, that the afternoon will be, I will be refreshed enough. But if not, still, we can do it. This is a very short book, so no